Okay, now we have FMECA. I told you this one is the bottom up technique, and FMCA is a failure mode and effect critical analysis. This is the critical analysis, and failure modes are also present, and there would be the effect would be defined on these failure modes, and it is a critical analysis. Okay, this one is the critical analysis. For bottom up technique, what is meant by this bottom up technique and the top down technique? See, in bottom up technique we'll go from bottom to up. Bottom up means we are going to do our analysis from down to up, and in top down technique we are going to do our analysis from top to down. See, in bottom up technique we will be seeing we will be going from bottom. So we have to see, like suppose we have a system, and that system must be having different subsystems, like a system that has different subsystems. Suppose it has 4 subsystems, and each subsystem is being divided into components, and it may have 3 components or 4 components or 5 components and so on. So this is the way of defining our system. Okay, a system that is divided into different subsystems, and each subsystem is being divided into different components. So what this bottom up technique means, like we are in the bottom. Okay, here we are in the bottom, and here we are in the top. So we are going from bottom to top. And what this bottom is like, first we are going to work on our bottom one. Okay, so first we are going to work on our component 1, then component 2, then component 3. Okay, and then we are going to work on our subsystem 2 and the components that are under this subsystem. We are going to work on those components, then the 3 one, then the 4 one, and so on. So that means we are doing the bottom up technique. We are going from bottom to up. Okay, that's all. And what is the top down technique? In top down technique, first we see that we go from top to down. First we see the system. Like we have a system, we have what we can say, we have you can say we have something like we have a power detector, or we have power water stream or something like that. Like we have a system, we have a complete big system. Something is happening in that system. Like take a little example of a room in which we have light, so that the possibility of that light being failed or not failed. So we are talking about the system, complete system. So first we will see the system, the possibilities that are there for that light in the room, for that light got failed or not, the possibilities of that system. Okay, the failures of that system, and what can be the possibilities, and then we are going to go in the downward. So first we are going to see the system, so that's why that is called the top down technique. And for top down technique we have FTA and ETA. These both are top down techniques, and FMECA is the bottom up technique, that is going from down to up, from bottom to up. So first we are going to see our components in our circuit. So here we have a circuit, that is, we are now in this video we are going to describe in detail FMECA, what is the method of doing this FMECA. So suppose we have a circuit. Here we have input voltage and the resistor, LED, this capacitor, and we have voltage out. Okay, the output voltage. This is our circuit, and we say that first we are going to work on component 1, because this is our bottom up technique. So first we going to work on our component 1, that is our resistor. Okay, So okay, in this method FMECA, in this technique, remember we are going to do our 5 conditions are present. So we have to first we have to do our these 5 conditions. First, what we have to do, we have to identify, like I have defined everything here. Okay, everything is written here, so you can see it. It's not anything different or anything difficult. Okay, the first condition is identify all the failure modes of the system. So we have first to identify all the failure modes of the system. Suppose we are talking about this R. First we are talking about our resistor. So we have to identify all the failure modes of this resistor. Okay, and the next point is relate the causes, effects and hazards of each failure mode. So each failure modes, we have this resistor and its failure modes can be short or they can be open. So a resistor can be short or open. So what we have to do in point 2, we have to relate, like if we have the failure mode short, so what would be the causes and effects and hazards of that failure mode, or if we have the failure mode as open, so what would be the causes, effects and hazards of that open failure mode. Okay, so now it's really easy, it's nothing that difficult. Okay, now the third part. What is the third point? Assign to each failure mode a probability of occurrence. So we have that failure mode we have got. Okay, now the failure mode is short. First we take the failure mode as short, so we have to assign a probability of occurrence. See, probability of occurrence to each failure mode. Okay, and the fourth is assign a severity of consequence for each failure mode. Okay, now the next point is that we have to assign a severity of consequence, that what would be the consequence for each failure mode. Like for short, what we have the severity of consequence, and what we have for the open one. And then the next and the last point, give a priority. A priority is, what is this priority? RPN, that is the risk priority number. We have to give the risk priority number to our each failure mode, either short, either open or anything else. So how this risk priority number, I'm going to discuss it later, how we can define this risk priority number. First, let's build our table here. So what we say, we are talking about component 1, and we say component ID. What is our component ID? We are talking about resistor. That's why we write here resistor. We have first component, our first component is resistor here, so that's why we write our resistor here. Okay, now let's say what I told you, identify all the failure modes of the system. So all the failure modes of the system, so what we have the failure modes can be, for a resistor it can be open, short or intermittent. Okay, now the next is consequence on system or subsystem. Like what are the consequences that are going to be, what are the consequences that can be happen to our system or subsystem. Like this is our system, or it can be a subsystem, we don't know about it. So that's why what would be the consequence on this our resistor to be short or open with different failure modes? What can be the consequence on our whole system or subsystem? So let's see, when we have open failure mode, when our resistor is open, we say low pass not working. So this is our circuit for a low pass filter. This is our low pass filter, and we say when we have resistor open, our low pass is not working, and when we have our resistor short, we say either low pass not working or can be partially working. So for short we have can be partially working, and for intermittent, not affecting low pass filter. Intermittent is the term when this resistor, the resistor is not affecting our low pass filter. So either it is in the position of, it is in the intermittent form. So this means that our failure mode is intermediate. So this means that the resistor won't be affecting our low pass filter. Got it? Now next, what we have, O. So what we have done till now, we have relayed the causes, effects and hazards of each failure mode. So we have done the causes and effects that are going to be on our system. Done. That is done. Okay. Now third point is assign to each failure mode a probability of occurrence. So first we will say occurrence. We do our table for occurrence. Then it's saying that assign a severity of consequence to each failure mode. So then we have assign S here, we have assigned our severity here, and then D is the detectability. Okay, we have another thing also here, detectability, right? And the fifth part is give a priority, RPN, risk priority number. It's just that here we have severity of consequence as here, so it's you can add another point, fifth point, as we have to detect, we have to do the detectability of each failure mode, so you can add another point, and the sixth point would be this point would be the last point, that is give a priority, that is RPN. So how we can find our risk priority number? It's easy, that we multiply all these three terms, O multiplied by S multiplied by D. When we multiply these three terms, we got our RPN. Suppose our occurrence is 2, severity is 1, detectability is 10, so 10 to the 20. Occurrence is 5, severity is 1, detectability is 10, so 10 5 is 50. Occurrence is 1, severity is 1 and detectability is 10, so 10 ones are 10 and ones are 10, so it is 10. So RPN is basically the product of our occurrence, severity and detectability. So now how these three things, occurrence, severity and detectability, how are they being presented? Let's have a look, because only this thing is left. Then only I've told you how to write this, how to present this, okay, and how to do this. Only this thing is left, that is how this 2 1 10 and 5 1 10 and 1 1 10, how these things comes out, because these are the main things to find our RPN. Okay, we have now another tables for occurrence, severity and detectability. We say we have occurrence from 1 to 10. Okay, we say we have occurrence. This for this it can be defined in our question, or it must be defined in our question. We have an occurrence from 1 to 10. For occurrence when it's 1, we have how many events? We have 1 over 1 million events, right? And we have, when we have occurrence 10, we have 1 over 2 events. So all this thing would be defined in your question, that how much occurrence we have. For 1, when we have 1, our events would be 1 over 1 million events, and when we have 10, our events would be 1 over 2 events. So this would be defined in your question, like you got the question to draw or to represent FMECA. So all these things would be defined. You will be having a circuit, right, and you have to draw and you will having the occurrence, severity and detectability. So it would be mentioned in the question and so on. So that's all, you have to draw this table, and you know how to draw it, how to find out this RPN. Okay, I hope everything is clear and it's not blurred. And for severity, we have on 1 we have no consequences. I have just supposed these things, right? For you, everything would be mentioned in your question. So for severity, we have 1 when we have no consequences, and 10, on 10 we will be having multiple casualties. Okay, there would be multiple consequences. And for detectability simply failure mode can be easily detected. On 1 we would be having a failure mode that can be easily detected, and on 10 there is no detectability. So different conditions would be given. For one, we'll be having that failure mode can be easily detected, and for 10 we are having there is no detectability. So got it? So that's why we have these all things would be mentioned in your question. And now how we did this thing, we take our first occurrence when we say that our low pass not working. We take first occurrence as 2. Okay, we take first occurrence as 2 and severity as 1 when we have no consequences because our low pass not working, so we have no consequences. And for detectability we have 10 when there is no detectability because our low pass is not working, so we take it as 10. So we multiply each term and got 20. And for the next one, when we say that it is partially working, what we write here, 5. Partially working means half in the working position, so we take 5. We wrote 5 here, and severity is 1. So 1 we say it has no consequences, 1 here. And for 10 we say 10 there is no detectability. So this all would be mentioned in your question. Every conditions would be mentioned, and according to those conditions you have to draw your table, you have to draw your these things, these tables also, and you have to find out your occurrence, severity, detectability and RPN for all these terms. And now it's last, I told you what RPN is, risk priority number, that is the product of occurrence, severity and detectability. Okay, that's all for this part. I have described FMECA in a much satisfying manner, I hope so. So in the next video I'm going to discuss ETA, this event tree analysis I am going to do with the ETA, that is our top down technique. So if you want to know about ETA, so you can go in my next video, you can see my next video. And this was the other part would be in my next video. Okay, so that's all for now. Thank you.